Hello everyone, it's Salar and welcome back to our tutorial, a tutorial to writing a real-time operating system. And in this part I want to say you heap memory is a resource. But what this means, heap memory is a resource. To describe this sentence, let's see this slide. When you want to allocate a memory from heap, you must call a malloc function. And when you want to free this block, you must call, for example, free function, or for example, sometimes you call realloc function. But as an example, when you call a malloc function to allocate a memory, neolib, the standard library from GCC, starts to allocate memory. It's trivial and obvious. Neolib starts to allocate a memory. But if meanwhile of allocation, between allocation process, if meanwhile of allocation a context switch happens, and next thread after context switch another time wants to use a malloc function, there will be a conflict. I will say when you want to share a resource between some threads, you may have conflict. And to get rid of these conflicts, you must lock your resource by using a matrix or semaphore. Okay? So when you call a malloc function, you'll start to allocate memory, but meanwhile, you have a context switch. And after context switch, another time you want to use a malloc. There will be a conflict. So before using a malloc or free function or realloc function, you must, and library must, lock this function. For example, a malloc, lock a malloc. But the locking function and unlocking function is a standard function from neolib. Okay? If you search in Google, for example, malloc lock neolib, in this website, documentation of neolib from Red Hat, okay, you will have some information about a malloc lock function. Lock memory pool for malloc and free. Okay, this is a standard function in this header file. In this header file, malloc.h, malloc lock and malloc and unlock. When you want to use malloc and free, first this function lock the malloc. After allocating the memory, unlock the memory allocator. Okay, but we must implement this function in our project, in our, for example, RTOS real-time operating system. So before allocating memory, the neolib lock the memory allocator. After allocating memory, unlock that. Okay, but let's see how can we implement these functions. I've implemented these functions in this C file, memlock.c, okay, in source directory. I've implemented these two functions, malloc lock and malloc unlock, from this header file, malloc.h. You can use a matrix to lock and unlock the memory allocator, but before inspecting these two functions, let's see an example. I have an example here. I have a thread 1, and in thread 1 I want to allocate a memory block by using of a malloc function. Let's debug this example and see the results. Okay, this is my example. If I run my code, the debugger jumped to this line and I want to run malloc function to allocate memory. But before that, let's put 2 breakpoint here. If I run my code, first jump to malloc function before allocating memory to lock the malloc function. Okay, and if kernel is started, I will say you what is this variable. Okay, kernel started value. If kernel started, acquire heap locker matrix by using of this function kernel get heap locker matrix. But what is this variable? Where is this variable? This variable is a member in kernel control block here, heap locker matrix ID, and by using of this matrix you can lock the malloc function. Okay, and this variable initialized here. Create a matrix, a recursive matrix. I will say you why we need to define this matrix as a recursive matrix, and set this variable by using of this function kernel set heap locker matrix. Okay, if kernel started, acquire this matrix and get this matrix and lock the matrix by using a matrix get. If the status value is okay, is status okay, break the while loop and run malloc allocator. And after allocating memory, unlock the malloc by using of matrix release. And after that, return here. Okay, so newlib uses these two functions to lock and unlock the memory allocator, but you must implement this function by yourself. But let's talk about kernel started value. Where is this variable? This variable is here in kernel.c, and this is a global initialized variable, and say kernel started. But why we don't use a state, kernel state, to find out kernel is started or not? Because sometimes before kernel initialization, before RTOS initialization, we want to know kernel is started or not. And kernel state, this member will be usable after kernel initialization. Okay, after kernel initialization. But because this variable is global initialized variable, even before kernel initialization you can use this variable. But in kernel start function, where is kernel start function? Here, in kernel start function, before starting the RTOS, you must set this variable to kernel started true by using of this function kernel set started value. So before kernel initialization you can use malloc lock before starting the kernel, and if this value is false you can easily use malloc function. But if kernel is started, first you must acquire the lock, the malloc function, and after that use that, okay, by using a malloc lock function. But you can see I've used matrix in this function, so you can't use malloc and free from interrupt, because you can call matrix get and matrix release from interrupt. If you use malloc and free now After implementing these two functions, if you use malloc and free from interrupt, this status value, return value of matrix get always will be error, because you can't call matrix get and matrix release from interrupt, and your code will get stuck in this while loop because always a status value is error. So you mustn't use malloc and free from interrupt. From this part you mustn't use. In next part I will say you how you can allocate a memory when you want to allocate a memory from interrupt, okay? But by using of malloc from this part, since this part you can't use malloc from interrupt. Okay, very good. This was implementation of malloc lock and malloc unlock function. These two functions from newly standard library. Okay. Now, heap memory is a resource, and we can use this resource heap memory in our operating system completely safe. Thank you very much to see me, and see you soon in the next part. Thank you very much.